after these explanations, let me explain you the global distribution pattern, the seismic belts and anomalies. In this regard, I will start with the Circum-Pacific Ring of Fire. Encircling the Pacific Ocean, this belt accounts for approximately 75% of the world's volcanic activity and 80% of the major earthquake. It results from the subduction of the Pacific plate beneath surrounding continental and oceanic plates. Notable segments include Japan and Mariana Arc, characterized by complex plate interaction between the Pacific, Philippine Sea, the Eurasian plates, Japan, that experiences frequent mega thrust events, exemplified historically by the 2011 magnitude of 9 Tohoku earthquake. In 2025, Japan recorded a significant magnitude 6.8 event of Miyazaki, generating a 20-meter tsunami and causing structural damage. The next one is Andes and Central America. The subduction of the Cocos and Nazca plate beneath South America generates deep and shallow seismicity. A M7.6 earthquake struck Honduras' Swan Island in February 2025, while Chile's Magallanes region experienced a M7.4 offshore event in May. Cascadia subduction zone, stretching from northern California to British Columbia. The seismic gap has not ruptured since 1700 but is capable of generating a magnitude of 9 plus event. Though quite in 2025, its potential exemplifies seismic risk in regions with long recurrence intervals. Now let me explain you the Alpine Himalayan belt. Extending from the Mediterranean through the Himalaya into the Southeast Asia, this belt forms a collision boundary between the northward moving Africa, Arabia and Indian plates and the Eurasian plates. Key features includes Himalayan frontal thrust, the ongoing collision close to 5 cm per year, builds the world's highest mountains and generates devastating earthquake. The 2025 M7.1 Tibet earthquake that happened in China, which killed more than 400 people, illustrating the extreme vulnerability of communities in this belt. You can see the major earthquake in 2025 along the global seismic belts in this table. In March 28, in Myanmar sagging, the magnitude was M7.7 and the tectonic context was sagging fault. It was a transform type. If we see the fatalities, that has caused death of 5,456 people. In January 7th on China and Tibet, the M7.1 tectonic context was Himalayan collision that caused 126 to 400 fatalities. In February 8th, Honduras, Swan Island, M7.6 in Caribbean subduction. In May 2nd, Chile, Magallanes, M7.4, Nazca subduction, and in January 20, Taiwan, Dapo, M6.4, Philippines Eurasian convergence. Now let me explain you the mid-oceanic ridges and the intraplates region. This is associated with the mid-Atlantic ridge. Earthquakes here are frequent but rarely exceed the magnitude of 7 due to thin oceanic crust and high temperatures. The May 2025 magnitude 6.2 event near Bouvet Island in South Atlantic released energy equivalent to 2.1 atomic bombs yet caused no damage. Stable continental interiors, while less active regions like North America's New Madrid zone remained hazardous due to the ancient fault within otherwise stable crust. The 1811 to 1812 earthquake, that was of magnitude of 7 to 7.5, caused widespread liquefaction, and modern monitoring indicates persistent though low rates strain accumulation. Chemically associated seismicity. Magma movements generates earthquake swarms such as near Hawaii or Italy's Mount Etna. While typically modest in the magnitude, they can precede eruptions as seen during the 1980s Mount St. Helens collapse. Another factor is human factor, the vulnerability and amplification. The first one is site effects and seismic wave amplification. What is it? The local geology profoundly influences shaking intensity. Soft sediments, for example, river delta, lake beds or landfills amplify seismic waves, especially longer period motions affecting high-rise buildings. Bangkok's clay basin, situated 1000 km from 2025 Myanmar epicenter, Bangkok suffered disproportionate damage, including a fatal high-rise collapse. Its marine clay layer amplified long-period waves, resonating with tall building constructed before modern seismic codes. That was in pre-2007. Now, another factor is valley and basin effects. What is it? Sedimentary basins like the Tepi Basin or Los Angeles Basin trap and focus seismic energy, extending shaking duration. The 2025 Dapu earthquake in Taiwan demonstrated how rupture directivity towards populated areas increased damage severity. Another factor is urbanization and seismic risk. Rapid unregulated urbanization in seismically active regions created disaster trap. Myanmar's urban centers, Mandalay and Sagaing, lie directly on the Sagaing Fault. Poorly engineered masonry structure and religious buildings, over 8,300 pagodas and monasteries destroyed, contributed to high mortality. Legacy infrastructure. Oldest building lacking ductile reinforcement failed catastrophically during strong shaking. The 2025 Tibet earthquake destroyed homes in rural China, while the 2025 Dapu event damaged structure built over the unrecognized fault linkages. Now, what are the political and social vulnerability associated with the earthquakes? Myanmar's ongoing civil war hindered disaster response, delaying in aid delivery and accurate casualty assessments. Earthquakes' impact are thus magnified by pre-existing conflicts and governance challenges. What are the indirect impacts? The tsunamis and landslide. Tsunamis, earthquakes. Let me explain you that. Subduction zone rupture displacing the seafloor generates destructive waves. The 2025 Miyazaki quake triggered a small tsunami, while historical events like the 2004 Indian Ocean tsunami demonstrate this cascading hazards. Now, another factor is seismically triggered landslides. Mountainous regions experience slope failure during shaking. Child's May 2025 magnitude of 7.4 earthquake caused landslides, while a January 2025 M66.1 event near Kalama Child disrupted power and water via landslide too.